Hello and welcome to this session at the PASS Virtual Summit 2020, which is about Azure SQL and why this is a best choice for building backend REST APIs. My name is Silvano Coriani. I'm a program manager in the Azure SQL team. And with me, there's Davide.
Hey, Silvano, how are you?
I'm doing good, thanks. Davide, which is also a PM in the SQL team, and you are delivering this session together through this kind of virtual setup to discuss about Azure SQL with you.
Yeah, right. And we had the idea to try to deliver this session as a discussion between me and Silvano to make it a little bit more entertaining and more also interesting to hear. So, of course, let's get started, right? Yeah, thanks to the PASS for hosting this summit as usual, and all the local groups. And remember to do the session evaluation, as feedback is always super important to improve. And now just a little bit of introduction. So a few words on myself. Davide Mauri, as Silvano just said, Azure SQL PM since a couple of years ago, before I've been an MVP for a long time. And I also have the pleasure to introduce a book that I wrote with Silvano, another guy that I pretty sure you already know, that is exactly covering what we are going to discuss today. So a practical Azure SQL database for modern developers. So how to use Azure SQL to create modern application. Well, that's it, right, Silvano?
Yeah, absolutely. And just a few words about me as well. Being a developer for a long time myself, then around 10 years ago, I joined the SQL Cat team, where I did a lot of kind of development and query performance tunings and so on, working with a lot of customers around the world. And I just recently joined the Azure team as a PM, Azure SQL team as a PM. And I had the pleasure to kind of co-write this book, where you will learn a lot of the techniques and tools that we are talking about today.
Agenda. So we will discuss a little bit on what means to be a modern developer and what is modern development today. And then we'll move to see some of the feature and the discussion that are around this idea. So of course, we start with JSON, and then we will see how Azure SQL actually can be used on any platform and with any language. And then we'll discuss something very core to modern developers and modern application, which is scalability and performance, of course. And then also CI/CD pipeline, how Azure SQL can be part of a modern CI pipeline. And that's something very cool and I would say bleeding edge, GraphQL, right?
Yeah, GraphQL. We wanted to show that there's also a way to design your backend APIs through this standard, which is, again, it's been introduced by Facebook a few years ago, and which is great for creating this kind of API layer to serve data for mobile clients or single page applications and other applications like that. We will go through that.
Nice. Okay, let's start discussing a bit what a modern application is and how Azure SQL actually fits into that picture. So there is no real definition of what a modern application is. There are many. I kind of try to look on the internet what are the most common, and it seems, of course, they need to support multiple clients. So that you can connect to it via mobile application, via web application, via something that will happen in future application. So it's clearly the ability to expose an API is a core value for a modern application. And exposing an API means also to expose data so that it's available in a generic consumable format, which today usually means JSON. Maybe will change in future since JSON is a little bit, verbose sometimes. But today, I would say JSON is probably the most common way to expose API. Don't know if you have some other things to add here.
Yeah, I mean, the data format that is going to be shared and consumed by different maybe client front ends or applications is definitely super important. On the other hand, all those kind of critical capabilities like scalability, like resilience, are important, especially in this cloud space where things are distributed in nature, and sometimes when our distributors, they tend to fail, or some components can fail. So being resilient to this kind of faults that you may have is very important. And we have a lot of techniques. We'll talk about some of the techniques to achieve more resilience in your application.
Yeah, exactly. And that is super important because, as you said, fail will happen in the cloud, and so you have to be able to manage that. And also because since you always want to have your application, available so that user can use it, you also need to start to think your application so that it will be easy to be evolved, upgraded, improved, and so that's why we also need a CI/CD pipeline. And also, you also want to make sure that the application is absolutely secure from the moment you start to develop it, and not add secure like a cool feature later. Security must be designed into the application. So that's I think what is commonly referred to as a modern application. So now let's see how Azure SQL can fit and satisfy all these requirements that a modern application have. So I will start with JSON support, because we said an application must expose API, must expose API and data through a common consumable format. And luckily, Azure SQL supports JSON natively, which means that it is able to receive JSON, like, for example, this JSON you see here. And with some specific function, we can extract values from, or objects from JSON, like the entire object here, or just maybe a value. But also we can turn JSON into table. Now, this may be something weird to think, because you probably want to think as JSON as a complex object. But in reality, at least in my personal experience, and I would love to hear yours, JSON is true that is very flexible, but it's also very common to receive once the JSON has been defined, just continuously repeating pattern of JSON, like the one we see here, right? So if an order as a schema, as a shape, is not that every time someone make an order as a different schema. The schema will be repeating. So it's kind of comfortable to be able to turn this JSON into a table, because actually a table is more suited to handle big amount of data, at least in my opinion. So it's I would say it's very common for Azure, for us with Azure SQL, to use OpenJSON or for JSON to turn JSON into a table, and then the table back into a JSON. So my feeling is that here we can basically have the best of both worlds, right?
Absolutely. And by the way, the relational table here may be hosting, the most critical attributes of the JSON payload, of what the application needs to actually manage. This doesn't mean that you cannot store the entire JSON fragment somewhere. It can be in a column of this particular table, or it can be in a different table, and then you can apply all the best practices and the horsepower of the relational engine to deal with kind of relationships, and to deal with kind of filtering, and the ability to use indexes to support queries, and so on. So it's definitely the best of both worlds, where you can manipulate JSON provided by the application and application developers, and you can respond JSON to application developers, but you can treat the data types with native support within the engine to make sure that you can get performance scalability on your solutions.
Yeah, and that's super cool, because as a developer, so let me put my developer hat here. I don't really want to deal with tables and columns and rows in my application. It's much better for me to just deal with something that can be easily deserialized or serialized into an object. And for that, JSON is perfect. But then my understanding, again, if I put my head as a good developer, my understanding is that data, it's probably easier managed by my data guy. I wouldn't say database administrator, but more like a data engineer in a relational format. So this means that I can see the same data in a format that it's more comfortable for me. But then at the same time, you as a data engineer can treat data as you think it's the best for performance, security, manageability reason. And we don't have any more, let's say, conflict using JSON as a way to basically glue application and database together, right?
Yeah, absolutely. As I was saying, we can get the best of both worlds.
Yeah, cool. Okay, so I have prepared several samples on JSON. Now we will go through that very quickly, just because people probably want to take advantage of what they are learning right now and maybe try it right away. So here, this website that will soon be moved into Azure Samples, but everything will still work if you point to this URL. You can see that we have created several IPython notebooks, so that you can use to start to get confident with JSON, just starting to query JSON. And actually, what is interesting is within Azure SQL, you can actually modify JSON in place. So you don't have to move the JSON outside SQL to change it in case you need to change the JSON. You can actually create some JSON. And as you were just saying, Silvano, you can even index JSON.
Hey guys, friendly interruption of the session because yesterday when we were recording the demo, there was no way for us to make IPython notebooks work on GitHub. So I just want to make sure that you see how cool IPython notebooks are, because right on GitHub you can click on a notebook and see the result right there. You don't even have to have the IPython notebook running on Azure SQL or SQL Server. So if you don't have any Azure SQL instance or database at hand and you want to learn JSON anyway, you can easily go on GitHub, or at least take a look at the IPython notebook and see basically the query I will be showing in the session, and then see the results, so you can understand exactly how all the JSON feature in Azure SQL support. Back to the session now.
Okay, so I think it's better to see this in action right away. So let's move to Management Studio, where I have prepared a sample environment. And here, so you can see that I have, as you just were saying before, a table. In this case, I went a little bit to the extreme. So I just have an ID and then just a column containing JSON data. Now, this is not probably the best practice. Sometimes it can be useful. Sometimes maybe, as you said before, you want to maybe take the first name and last name, since they will always be there, we know, in this JSON, and put them in a specific column. Or maybe, as you said before, we can also even index those. But just for the sake of doing something extreme, let's see how to handle JSON in this case. So something I may want to do is, let's say, take the first row and extract the first name with JSON value. I can do exactly that. But I can do other more complex stuff. Now, I can even take a look at JSON as a, let's say, collection of key value items, because if we just think it in a very simple way, JSON is actually a key and some value, right? So this is exactly what OpenJSON allows us to do. For example, I can see all the properties that are at the root level of the JSON, and then all their values. And so maybe it is useful in some cases, especially when I have to deal with arrays. But probably more commonly, what I would do is take the JSON and get some data and treat them as a table. So I want to say my first name property should be mapped into a first name in my hypothetical table. So with OpenJSON, I can exactly do that. Now, this is pretty cool, because from now on, my JSON will be treated like a table, and I can do join, I can do whatever I think I may need to do on a table, I can do it here. So this is pretty cool. And also, it's interesting to see that one of my JSON had more than one document stored in it, so it was an array, and it was properly managed, and in fact, the same document ID appear here, mean that it's true that I have three rows in my table, but one row has more than one document. So you can see that I can easily manage also the situation when JSON is not just like one document, but an array of documents. So it's really pretty cool. And that will basically means that I can accept a JSON, for example, as a parameter of my storage procedure, and then from that parameter that is JSON, I can turn it into a table and do whatever I need to do within my storage procedure. So developer will send me a JSON, but I will actually operate on it as if it were a table, which again, as we are still saying, is basically the best of both worlds. We can also do interesting stuff with JSON. We can modify JSON if we want. There is a specific command that allows us to modify JSON if we really need. So let's say I create a new user, and I only insert the first name and the last name. And then at some point I want to update the user's data by changing the last name. I don't have to necessarily move the JSON back to the application and then do the changes here. That's something that may be still good to do if I, for any architectural reason, I decide to do so. But it's not that it's the only option. It's not that it's the only option I have. So I can decide where I want to do my change. And here I can use JSON modify to say, okay, last name must be green. And that's it. If I now select from my table, and I will go and take a look at ID, let's say ID where equal 42. Yeah, now it's green. So I really have all the option here to manipulate JSON. And the interesting part is, let's say instead now that I already have an existing table that was never meant to be a JSON table, right? So maybe I have an old application or existing application, and I'm wondering if I can take advantage of JSON even there. So let's just say that we already have a user and a user address relational table, pure relational table. So columns are columns, and nothing fancy or exotic here. Can I turn this into JSON so that my developer can enjoy the fact that they don't have to, manipulate columns and rows and just object instead? Well, yes, I can just do for JSON, and let's say auto for now, and automatically Azure SQL will take the result and create a JSON for me. So that's pretty cool, because this means that my developer can easily receive this information as JSON and then deserialize it into, for example, a user object. So this really helps developer and data engineers to I would say get along well, very well together, which it was not so common back in the days. So with JSON, I can go on for hours and hours, but actually you also have something interesting to say around JSON. If I remember correctly, one of the important thing about JSON is that of course, it has some CPU usage, but impact on performance is actually not that bad. So actually JSON has a pretty good performance. Is that right?
Yeah, actually, some time ago, I happened to work on this kind of simple benchmark around storing and retrieving data from JSON fragments. This is a scenario that was derived from a real IoT application from a customer, and what we found out is that again, by combining the power of the relational engine and using proper indexing on top of the mostly kind of accessed columns and wherever there is a there is a predicate which is requiring, again, a dedicated index. We can create those indexes, for example, on top of calculated columns extracted from those JSON fragments. But there are some areas where, like, for example, storing JSON fragments in a relational table as is, and building a column store index on that particular table is also providing an additional benefit, which is the ability to get a lot of compression and compression ratio, so that you can literally store billions of these JSON fragments in a very efficient way compared to storing it as blobs or as kind of strings in any other database or storage engine.
That's pretty cool. And if anyone is interested, you wrote a very interesting blog post on everything you just said, so they can even test it if they want and hear the result details. So that's a pretty good knowledge to have, because then you can decide exactly when makes sense to use JSON, when makes sense to use the relational, when you have to go, something in between. Yeah, that's I would say that's absolutely interesting. Plus, if you are interested in JSON, there are a couple of other interesting posts or articles that we wrote, or that has been wrote over time. One is this one, how to exactly deal with JSON data in SQL Server, that goes in pretty detail. And also this other one is, again, another article on JSON that explains in details for JSON and OpenJSON that I showed before. There are several options you can use to be more or less strict, to make sure that performance are, exactly the one you're looking for. So JSON is a pretty important aspect of modern development. Make sure to check all these resources out and start to use it, I would say, because it is really, really helpful. I already showed some demo here, so I guess we can just skip that for now. And I felt it was easier for the discussion to show the demo at the time. So let's move to other interesting. We know that we can easily expose data and make sure the developer can efficiently use the data that we have stored in Azure SQL, no matter if it was stored in JSON or in any other format. Okay, here I just listed a set of features that are super useful for creating modern application. There is a full article that explains in detail all these features and gives resources to get deeper into the details of each of these features. But let's start discussing a little bit for each of them, starting from the multi-version concurrency control. This is something very cool, and nowadays I would say widely used also in other databases, where basically the integrity of transaction or the consistency of transaction is managed not by placing a lock, or not only by placing a lock on the row, which we all know lock can really be bad for performance, because they will reduce the number of concurrent queries that one can run on the same resource. So instead of using a lock, we actually take a snapshot of the data. So that's why it's called multi-version, because we keep several versions of the row, so that everyone can access the same row, even if someone is writing and someone is reading, without having to wait for each other. This is by default the Azure SQL transaction isolation level, and which means that right away on Azure SQL you will have less lock than on premises. Then there is change tracking. There is also a nice example on this. Actually, let me go right away again here and see where you can find the examples on everything we are showing in the session today. So if you just go here to doc.microsoft.com and then go on code samples, then you can go on Azure, search for SQL database here, and you will see many samples. We will go through them a bit today, but the one I'm referring right now that involves change tracking is, yeah, here we go. just in front of my eyes. So with this, you can easily create an application that take advantage of change tracking within Azure SQL, so that every time the client needs to get the new data from the database, is the database itself that is able to only newly added, changed, or deleted data without having to transfer the full data set. This means in today's mobile world, less battery consumed on the mobile side, less bandwidth used, so much more responsive application. So it's all these little things that make a difference between an average and a good application. And definitely, change tracking will allow you to create an application that is way smarter, but without having to write all the logic to keep the changes yourself, and just allowing Azure SQL to do its job and returning to you exactly what you need when you need it. So this is another very cool feature that not many developer knows that is available in Azure SQL, and that can actually change the way you create your application, making them way smarter. We have also talking about security, row level security, and again here there is another example that you can take a look here. Is about security, and here we go. Creating API to securely access data using row level security. This example will show you how you can actually create a table and make sure that every time someone queries that table, that someone will only see the rows that they are allowed to see. With a minimal effort, you will be able to easily create, for example, multi-tenant solution, or in general, make sure that anyone who's accessing your table can only see the row that they are supposed to see, without having to put all this complex logic within your backend. You can just be sure that the data that will leave Azure SQL to land in the backend to be processed will only be the data that that user is allowed to see. And again, this means that your application will be simpler and again more scalable and more performant. But there are other pretty cool stuff that can help application to be more performant and scalable. One is column store, right, Silvano?
Yeah, column store, I briefly touched on that when I was discussing about JSON, but column store itself is this columnar mode of storing data in relational tables, which is optimized for analytical queries, for serving aggregations, and basically boosting performance. Also on the HTAP, the infamous kind of hybrid analytical workloads that is typical of a lot of applications, where there's a mix of actually transactional and some analytical queries that are impacting the same data. Column store and in-memory tables, in-memory optimized tables can actually work together. You can build column store on in-memory tables and basically achieve what is called operational analytics. So while you are ingesting or are executing a lot of transactions on a lock-free in-memory optimized tables, you can actually build column store and run analytical queries on top of the same in-memory data. So especially for scenarios where you have a lot of concurrency, but you still need to do a lot of aggregated queries and such, the combination of these two tools that we have in Azure SQL is very, very powerful.
Yeah, and I think by using column store and in memory, we were able to achieve on an IoT scenario something like 5 million rows insertion per second. Is that right?
That is correct. There's a published blog post, an article about this kind of world record, and this record was actually achieved while there was a kind of analytical query on top of the ingested data. So this is even more impressive.
Yeah, that's impressive, and that, I mean, just thinking a little bit more broader, this also means that Azure SQL is perfect also for IoT, because we can have this, column store in memory and relational approach all together, just within the same system, which means you can create simpler application, but they can scale really high. Like 5 million rows per second is quite a number.
Yeah, and from a programmability perspective, we know that modern applications also sometimes need different paradigms in terms of development, and this is why Azure SQL is also offering Graph APIs. Which can let developers to create this kind of complex relations between kind of nodes and edges in this kind of graph structures, and hierarchies as well, where you have to deal with things like a complex bill of materials or informations that are natively representing hierarchies in nature, right? And at the same time, geospatial data types are also super important because these days there are a lot of georeferenced data that we are storing in our systems. Think about from pictures that we are saving to maps and other type of geographical information. And Azure SQL actually offers a native data type for this, which is giving us the ability to, for example, check when we are within a given set of coordinates, for example, and it offers behind the scenes a lot of these geospatial functions that, again, you don't have to bake into your code, but you can just use closer to where the data are actually stored, which is super important.
Yeah, especially today that basically everyone has a GPS system on their pocket, because with the mobile phone, knowing where I am and having context and knowledge about what is around me, it's important. So, just for in my test, I did a lot of these geospatial calculation, and they are super complex. Having them basically embedded in the engine, it's amazing, because means that as a developer, I can just focus on developing my application, not dealing with this complex stuff that even if they are complex, everyone today expect, right? Everyone today expects that my application has some knowledge on where I am, and the fact that there is some GPS coordinates that I can use to do something. Like even photos today, when we post photos, are geo-tagged, right? So making my modern application can handle that is much easier if I have everything already in Azure SQL and just have to use it. So that's something I really like. So let's discuss now how a developer can use all this goodness. I mean, like, okay, I'm a .NET developer. I can expect to be able to use all these features, right? But what about Node or Python or Go? Can developers using these, let's say, different languages take advantage of all this goodness, or is just only for .NET developers?
No, it's definitely not just for .NET. Actually, Azure SQL is offering a lot of client drivers for different programming languages, for different execution frameworks. So starting from kind of Node, Python, Java, Go, we have a lot of different client drivers, and also more complex kind of data access libraries. If you think about ORM frameworks, for example, right? So we have, of course, Entity Framework on the .NET platform, but you can use actually other ORM tools with Azure SQL that are perfectly compatible. Hibernate, for example, in Java, but we have most of the other ORMs like SQL Alchemy and many more that are actually perfectly usable with Azure SQL.
That's pretty cool. So basically, I can take advantage of Azure SQL if I am a Linux developer using Node, for example, right?
Totally.
Cool. And we have an example for that. For example, I kind of already prepared here this this page. Again, it's always under code samples, but you can see that we have created the To-Do MVC sample application. Now, the To-Do MVC, it's a very well-known application that has been developing in the past to showcase how to create a common to-do list application using basically all the most common front-end framework, right? So Today, yeah, they started with Backbone back in the days, Angular. I love the one in Vue, for example. So basically, so this is how to do that. That's what this application does. Now, this front end is completely built in Vue, and it stores data locally on basically a local storage of the browser. What we wanted to do is to show how easy using JSON, for example, because behind the scene, all this stuff is JSON, right? Can be sent to Azure SQL, be processed with an Azure function that runs Node, and then store the JSON into a table or as a JSON format in Azure SQL. Again, here you have the full sample that guides you through deploying the web application using a new service called Azure Static Web App, but it could be any web application on Azure, using Vue as a front end, using Azure Function and Node.js to build the backend, and Azure SQL to store data. Let's just take a look at the code and see how simple it is, thanks to the JSON support, do that. So the database, for example, it's very easy. I just created a to-do table, and as you can see here, it's pure table. It's no JSON. I stored my to-do as an varchar of 1,000, and if it's completed or not as a timing. But I know that my developers would love to use JSON. So the procedure that will serve the GET request that will come in from an API, because again, I'm trying to build a modern application. So I'm not building something monolithic. I created my front end in Vue. I will create my backend with the function and Node, and then I create my database on Azure SQL. But I know my developer would love to have JSON. So that's what I'm doing. When the developer will look for the to-do list in Azure SQL, they will only have to call the get to-do procedure that will basically do a for JSON path, which is another way to return JSON, but it's very similar to the for JSON auto we saw before, where I'm returning my to-do list as JSON. And the result will be exactly something that can be passed back to the Vue.js. So for example, let's take a look at the backend now. So I have my API, my backend, and this is completely done in JS in Node, as you can see. And the code is very simple. Basically, my function to do rest is called. It checks which kind of verb has been issued. So if it has to return the to-do list, it has to create a new post or update one or delete one, and then we'll call this execute SQL. Now, the execute SQL is really simple because this is very, very basic. It's open a connection to Azure SQL. It created the request object, and the only parameter it passed is the payload, and the payload is nothing more than the JSON that is received by Vue, that I will show you soon. And then it says, okay, just call the procedure. So as soon as the connection is open and working, call the procedure and return the result. So this means that my developer never has to deal outside this procedure, which they will only call this way with tables and rows and other stuff. It's just JSON. And it's just JSON so that basically I can even return the JSON as I receive it from Azure SQL to the front end, because the front end expects JSON. Azure SQL produce JSON, so the backend here is just basically making sure that the front end can talk securely to Azure SQL. That's it. Very, very easy. Okay, cool. Now that we have seen how we can create a full stack end-to-end sample, the other requirement that a modern application has is to be scalable, right? So we want to be able to scale up and out if needed to serve, the highest number of requests that we may think we are going to have. So we created also an example here that will show you how, for example, with Azure SQL Hyperscale, you can use Azure Function to autoscale, or even how you can just create an entire Azure SQL solution with Azure Function, with a front end. to scale even up to 20,000 requests per second, which is a very, very high number of requests. I would say, Silvano, that 20,000 requests per second should be more than enough, right? Or, I mean, on average, of course, there will be always exception, but on average, it's a pretty high number.
Yeah, absolutely. I think most applications we will never get to that level of scalability. But as you rightly said, in SQL we have different options in place. Scaling up is very interesting because right now we have the ability to scale up to 128 cores and a lot of terabytes of RAM as part of the highest service tier that we have in business critical when we use the M series compute sizes. But at the same time, we can also scale out. So part of the Elastic database tools, we have the ability to design solutions that are sharding data across a number of nodes. And can actually scale kind of horizontally and potentially reach some infinite scale, right? Because the more you need, the more nodes you can add. And we have some tools, both from an application development perspective, like the Elastic Database Client tools, that can help developers to write these sharded applications by providing a set of libraries that are simplifying this task. And at the same time, we have some management tools as well, like Elastic Jobs, that developers can use in order to, for example, execute tasks, maintenance tasks, for example, this sharded databases on multiple nodes, right? So depending on your needs, we can scale up a single node to kind of a very powerful compute size, or you can take a different design and scale out and shard your data horizontally across multiple nodes. So you have an example here that is showing a lot of requests per second, but I think we can even do more.
Oh, yeah, definitely. This and is a proof of it. This has been done with just Azure SQL Hyperscale 16 vCores. And just, as you said, we can scale up to 128 with the various Azure SQL offering we have. So just imagine how high one can go, even, thinking that also we can scale out.
Yeah, and we are talking about interactive requests here, not bulk loading or other ways to optimize inserts. So these are effectively kind of interactive requests that are hitting the database. So again, knowing that we can scale even more than this is really, really important for developers.
Okay, now that we have seen Azure SQL can scale to basically any limit we want to reach and beyond. The other big thing about modern development is the ability to be agile and to be able to deploy new feature and evolve our application quickly, securely, and in the most automated way. Because the moment you want to scale out even your application, is not that you cannot install manually the application on all your instances. You want to have a streamlined solution that installs the application everywhere. Of course, so this means that the DevOps and CI/CD pipeline is mandatory in modern development, and it's also important that Azure SQL can be put in that pipeline. Today, you can do that using backpacks or database projects, or even third-party solution like DBApp, which allows you to selectively apply Azure SQL scripts or T-SQL scripts to an existing database and make sure that when you deploy something, they are deployed, and maybe also run tests and make sure that the database is in exactly the state you want it to be. Let me show this here. It's very quick. It's a demo based this time on GitHub Actions. So here I have created an example. Again, this example is always in code in docs.microsoft.code samples, and you just have to fork this repository into your account. And the magic here is done by the GitHub Actions here. So this workflow where we are using, in this case, in this case, just we are just doing .NET Test or .NET Run. And the magic here is really done by this tool, the app, which is a tool that allows us to create an application and make sure that that application will correctly apply the SQL script in the correct sequence, and make sure that each script that has been already applied won't be applied again. So incrementally release improvement to my database. As this DB tool is actually a library, you just have to embed it in an application you create and then run it using a regular .NET Run tool. So this will allow you to deploy your script to the database you want. And then I personally like also to create a unit test for my database. In this case, I use it easily, an unit as a way to test. So for example, here, after I deployed my database, I want to make sure that my storage procedure, if I pass an empty JSON, return something that I expect. So I just want to make sure that this actually happens. Now, let me just try to commit something here. So for example, let's just do a very simple change. I could, download clone the repository on my machine and do everything, but just for the sake of this example, to keep it short, I will just make a very small change as to GitHub CI/CD pipeline. And once this will be pushed, what happens is that the action behind the scene will kick in. And as you can see right now, is executing the deploy action. And the deploy action, as soon as this will start, will actually, and let me open Management Studio here, will actually execute script on this database I have here, but it will automatically track what needs to be executed and what's not, because this schema journal table has been created for me by the tool in this case. And as you can see here, there exactly all the script that has been already executed. So any script won't be executed twice unless I explicitly want that to happen. So this allows you to create one way to create CI/CD pipeline and to make sure that your database is part of it.
So let me check if I got it correctly, Davide. So we are using here one interesting library, which is a .NET library. We can embed that library in our own .NET applications, and together with the SQL scripts that we want to execute against our databases within this kind of CI/CD pipeline, and then we can trigger the execution of that application by using GitHub Actions the moment we are changing something in our development repository. Correct?
Absolutely.
Pretty cool, right? And I know that there is also an alternative approach, which is a more declarative approach, the one that we use as part of our DAC pack or backpack formats, and where we can effectively declare the state of the database we want to have after a given change that we are executing in the schema. Then we can basically bake those changes as part of the database model by using, again, SQL Server data tools, or to use all the different libraries and code frameworks that we have available, and then run those, basically apply that model to an existing database, and the DAC framework will basically generate all the different differential T-SQL in order to change the state of the database at the end of this, right?
Correct. So as you said, basically the DAC pack is a snapshot of the database in the state that you want it to be. So it's up, in this case, to this action called Azure SQL Deploy to take your DAC pack and find the differences between your DAC pack and the database you are targeting, and apply all the changes needed to bring the database to the same schema, and if you also want, with the of the DAC pack you have. So this is, as you said, a more declarative approach. Actually, there is a third one that is the one provided by tools like Entity Framework or Django in Python, where you actually have your object model and you want to do what are called the database migration. So it's the code itself that will actually apply the changes needed to the database in order to reflect the new POCO object, for example, you are dealing with, or the new Python object that you have created for Django. So I would say there are three options that covers, I would say, all the possible ways someone wants to deal with database. Code first, database first, or manual script, like I've shown here. So that's should make every developer quite happy. Oh, that's something very bleeding edge, right?
Okay, yeah, definitely. So far we've been discussing about REST APIs because we know that for designing backends, the REST kind of way of developing APIs over the years have been pretty successful, right? But more recently, we have seen, emerging other ways of defining our backend APIs, and GraphQL is definitely one of the most successful one, right? This is coming from Facebook, and if you think about how modern applications, especially in the mobile space, but even in the web space, need to basically access different data, query different data, and compose data together, the REST model can be a little bit challenging because every time you have to change something or you have to merge data between different data models, this requires basically you to develop yet another REST API, basically that is offering, as to the consumers, the data shape that you like, right? Yeah. But this was, if you think about, for example, the first release of the Facebook app, mobile app, that was developed with this REST model in place and was creating a lot of problems because, whenever we were changing the data in the backend or the shape of the data, they had to release new versions of the APIs and new versions of the application. So they came with this idea of GraphQL, where basically you are describing the model that you want to expose through these APIs, and basically you can query that model with the proper language, and you can get different results depending on how you are shaping the request, right? So once you define the model and the objects and the entities that you can query, then you have a new query language, which is again JSON based, by the way, and then you can get the results in different shapes and forms, right? You can get all the details about the standard that Facebook helped create at this URL here, but I wanted to, if the slide deck is supporting me, okay? So why this is being created? Exactly for the reason that I was mentioning, right? So the way basically to let consumers to define the way basically their API endpoints were returning the data, and to be able to create again this consumable and composable endpoints to avoid this kind of a problem that REST-based design was introducing, right? Also the ability to return exactly the same, exactly the amount of data that were needed from the application, not more, not less than what the application actually required. When to use GraphQL? GraphQL is not for every scenario, right? It's great for when you're designing these kind of interactive front ends, applications like mobile apps or single page apps, and are great for designing the first line of interaction that these applications are doing with your backend. Maybe behind the scenes, GraphQL services or endpoints can actually invoke REST APIs, but this, the GraphQL endpoint will give developers the ability to reach out to a single endpoint and to do that declarative query mechanism that I was showing before, right? It's probably not the right way. It's not intended for to be used when you have, for example, a very high throughput or a classic kind of transactional kind of REST APIs where you're creating, deleting, or updating objects. No, this is where REST is still doing a kind of a very good job. Or there may be other protocols like OData, for example, that can be a better choice for that, right? From an architectural perspective, you can take a look at this diagram here, where you have, again, your apps, mobile apps or web apps that are reaching out to a given GraphQL endpoint by using this query language that I was mentioning, right? A JSON declarative way of what kind of data you want back from your service. And the endpoint itself is basically exposing a series of operations. Those operations are typically queries, so a way to retrieve data, or mutations that are effectively transactions that you want to execute on top of the data. And then another super important component is this resolver. The resolver is basically where you specify what is the model that you are exposing to be queried, and what are the entities that you are retrieving from various kind of backends for this endpoint, right? For example, you can query directly a database, or you can invoke another REST service, or maybe another GraphQL service, and then you can combine data and reply back to the client in the shape and form that you have described as part of this query language, right? This is the brilliant idea behind GraphQL.
That's pretty cool.
And the main concepts are, you have to define this model, so the schema where you describe the entities. You have to define the queries, so how you are interacting with these entities, retrieving data or executing those transactions on top of the data, and then you create those resolvers that are defining the interaction logic with the different data sources, right? And there are some more advanced concepts, like you can create data loaders, like lazy loading mechanisms. You can do paginations and filtering, sorting, and so on. But those are a little bit more complex concepts that we may look at more deeply in the documentation. But for now, what is important to understand is that we have libraries in pretty much all the different frameworks available to design GraphQL service, and we will take a look soon on how to do that. But pretty much all the languages and frameworks are covered, and there are very interesting libraries for all of them, right? What GraphQL has to do with Azure SQL? Basically, as we have seen, a database like Azure SQL can be the source for GraphQL endpoint, and the way you implement that, you have to implement basically your own resolvers, and those resolvers you can create the typical data access code, for example ADO.NET or any other driver, and do all the, let's say, plumbing yourself, or you can use one of the ORMs or micro ORMs tools that we have, and we will see this highly simplified the way you write a GraphQL service, because you basically let the ORM tools to do the magic for you in querying the database. That said, all the best practices are still applying here, right? So even with ORM tools, we know how to write efficient data access code, right? So because typically this is a disconnected scenario, you don't need to do, for example, enable tracking or stuff like that, which is typically an anti-pattern with ORMs. For you still can use kind of parameterized queries. You can use stored procedures in order to load those kind of ORM data models and so on. Right? So best practices are still needed, but we will see writing a GraphQL service is pretty simple. And consuming is very simple, because we have libraries available for pretty much every development framework. Again, all the cool kind of UI frameworks like React, Native, Angular, and so on are capable of consuming GraphQL service, right? So I think I already kind of spoke a lot, and I'm going to share something here. I do have an example Okay, I have some examples here on how to develop a GraphQL service with different programming languages, and I will start from the basics. So let me open up VS Code here. This is the simplest kind of Node.js GraphQL service that you can develop. We are using Apollo server here, which is a popular GraphQL server library here, and we are basically defining the schema that I was talking about, basically where we are showing up what are the entities that we are exposing through this particular service, order and order line, very simple. And then we are defining what queries we are exposing. So we are querying for orders, which is basically a collection of order entities here, and the single order, which has an ID, which ID is an integer here, so basically we are defining what the shape of the data that we are returning. And here I'm using a very simple array, JSON array, very simple, that is containing some data to show how to do that. And the resolvers that are the other important point here, where I'm in the resolver, I'm describing the two queries, the orders query and the order query, where I'm basically getting an order by ID. And instead, when I'm querying the entire collection, this is where I'm returning the entire collection here. I'm just creating a new instance, and then I'm listening on that particular HTTP endpoint, and everything works. So if I go back here to my folder, and I'm doing, and I'm executing my application. This is the endpoint. And by the way, out of the box, Apollo is creating this nice graphical playground, how we call it, where we can test our queries against our service here, nice. Right? So this is the JSON query representation that I was showing here. I'm asking for all the orders, and I just want to project the ID field out of that collection, right? So as you can see, this is the response JSON that we can manipulate with whatever client library that is capable of manipulating JSON, right? But if we see here what we can do, we can also change the way we are shaping our data, right? So we want to get also the order line collection here, which is again a property of our orders, and I want to know the ID and the quantity of the products that I just ordered, right? And boom, what I have here is a completely different response in terms of shape, right? So a single endpoint, different query language here, and different, of course, shape and data that I'm returning out of my database, in this case, out of my in-memory array, right? So these are the basic principles, and once we know the basic principles, we can do something much more complex here. Like, for example, we can use a .NET version of our service where I'm using entity framework here. Mm-hmm. So I'm taking this AF context where I'm basically querying different DB sets, so orders, order lines, and customers, right? So this is a very standard entity framework model, right? And I have my POCO classes here, very, very simple ones, right? And then what I'm doing here, I'm just defining, again, this is my resolver where I'm basically defining how the queries, so how to get the entire order set or a specific order. And what I'm doing here, I'm just using my entity framework context to return the entire orders collection, or to query on a given, for example, order ID here, right? So nothing really strange, very simple. But at this point, what I can do is
Silvano, the library you are using right now is called the Hot Chocolate, right?
Exactly. What I'm using now, I'm using Hot Chocolate, which is, again, a pretty popular option that we have in place. But I'm doing, I'm doing .NET Run here. Now I'm need to go back to my browser again. Okay. My playground, of course. So what I can do, I can start writing my code, my query here, sorry. Right. And again, I'm reading out an order. In this case, I want to filter on, I give a specific order. I'm saying order ID number 1, right? And I could just return order ID, for example, and sorry, there's a comma here, and order date. Okay, so I'm executing the query. Now, what I'm querying behind the scenes is my database. Okay.
Oh, cool.
So I'm now connecting to my Azure SQL Database. And as you can see here, I can do what I was doing previously. I want to know the order lines. And in the order lines, I want to get, for example, what is my stock item that I'm ordering here? And maybe, for example, the quantity. Okay. So, and here you get the response. Now, let's go back for a second to my console here, and here I'm logging my SQL commands, right? So this is what Entity Framework is effectively is basically executing. So as you can see, these are regular SQL query. This is where I was just querying my order collection, and whenever I'm doing effectively I'm reading out the master detail one. This Entity Framework, of course, is just executing a left join here, right? And it's managing all the SQL complexity for me, right? So I can keep my GraphQL service simple, leveraging an ORM tool like Entity Framework, and I can get back kind of very complex results out of the database by just again leveraging an ORM tool here. Or I could write all my traditional ADO.NET code in basically the standard way by creating my own resolvers. Okay,
that's amazing. GraphQL is definitely modern by all means, and I think we are just at the end. We covered a lot. There's a lot more to cover, so that you use this session as a starting point to understand, JSON, column store, row level security, change tracking, all the various tools that we discussed. Make sure to check out the examples in the docs.microsoft.com website. Definitely try out GraphQL. It looks pretty amazing to me. Anything else I'm missing here, Silvano?
I think we just really demonstrated that the battery included message that you like a lot about Azure SQL is actually true, and it's a very powerful tool, and we are just kind of looking forward to see what you will be able to develop based on Azure SQL in the future. Just let us know. These are our contacts. Please feel free to reach out to us and let us know if you have questions or if you need more details. We are happy to answer.
Absolutely. Thanks, Silvano. See you soon.
Thanks, Davide. And thanks everybody for attending. Bye. Bye-bye.